Hello, William. I'm going to try to answer your questions that you had on the quiz for Chapter 2. So you had a question about number 4. You said that you don't understand why the vertical axis would not reflect the score of the quiz. Alright, so basically, if you're looking at this graph, you should notice that it's a histogram, right? Or you can take it as a bar graph too, but it's a histogram because it has bars and the bars are touching, okay? So for a histogram, each of the bars, the height of the bar represents a frequency, okay? So basically, the height represents, this axis represents the frequency, all right? And that's true for all histograms. It doesn't matter what you're doing, you're counting how many items, or how many people are in each category, okay? So the numbers on the bottom are the variable. The numbers on the horizontal is like the variable you're interested in. In this case, it's like grades from a quiz. And the vertical number is the frequency, okay? So frequency means how many, right? The number of items there are in each category, right? So that's why the vertical axis does not represent the score, because it's a histogram. All histograms are set this way, with the horizontal being the variable that you're interested in, and the vertical always being the frequency or relative frequency if you want to change it to percentage, okay? All right. Alright, your next question is for number 10. So this is, you give a quiz to 45 students and determine the median grade. After grading the quiz, you decide to award the top 5 scoring students a bonus of 5 more points. The median of the new grade distribution will be equal. So that's the correct answer. So you said that you believe that it will be higher if the top 5 students receive 5 extra points. And you plug it in your calculator. Alright, so I'm not sure why it gave you a higher one, but imagine you have your 45 students and you write their grades down, okay, maybe from lowest to higher. So you have like the first maybe 30 and 35 and 43, and this is like the first 3 scores, and you have a bunch more, right? You have lots of students, you have 45 of them. So let's say this is the 41st student, and they get like 85 and an 87 and an 89 and a 92 and a 94. 1, 2, 3, 4, 5. Those are the top 5 students, okay? If your scores are arranged in increasing order, then the median is going to be this center number. So this will be the median. Whatever the grade in the middle is, that's your median. Now, if the teacher is adding 5 points to these scores to make them 90 and 92 and 94 and 97 and 99, this is not going to change your median because your middle score is not adjusted. You're not adding or subtracting values, so it's not going to shift the middle. So the median is going to stay the same, all right? So I can simulate some grades with StatCrunch. Let's go to StatCrunch applets and do random numbers. So I'm going to generate, let's say the minimum grade is 10 and the maximum grade is 100, and I want 45 grades. Alright, so let's see if I can put this, can I put it in a thing? No, alright. I'm going to take these numbers and put it in the column here. There you go. So here are my 45 grades, which you can see. But in that first column are my 45 grades. Okay. I'm going to arrange them from smallest, I'm going to say ascending. So I'm going to arrange them from smallest to largest. Okay. So you got to do that because you need to adjust your top 5 grades. You can't adjust any random 5 grades. That will change your median if you don't adjust your top 5 grades. So I'm going to copy that column, and at the very bottom 5, 1, 2, 3, 4, 5, I'm going to add 5 to them. So this becomes 96 and 97, 98, 99, and 103. All right, so let's find the median of each of them. All right, so we're going to do stat and summary stats with columns. So I'm going to do the first column. I'm going to click on the median, compute. So this gives me that the first column has a median of 54. All right. Let's do summary stats with columns var2 and the median. So second column, and the median is also 54. So again, these were random numbers, right? So again, your median with 45 students, your median is going to be the value in the 23rd place when you arrange these in ascending order. So there's no reason for why the middle number should change at all, because the only thing you're adjusting is the last 5 numbers. You're not adding them together, you're not adding more points, you're not shifting the center of the median in any way, so it shouldn't change. Alright, so for question 11, this is a similar thing to the previous question. So you have your data here. So they don't give you data, they just kind of give you the summary statistics. So like the mean is 31.52, median is 30, IQR is 34, standard deviation is 21.6, and the range is 132.5. So you're looking at part B. The class determined that a mistake had been made and the value was entered as 138, should have been marked 38. They recalculate all of the statistics. Which of the following must be true? So what's going to be true is that the mean is going to decrease and the median will stay the same. Alright, so again, the median shouldn't go down, because what you are doing is you have your however many students you're surveying. It doesn't say here, but like you said, you're using 100 points maybe. Alright, so 100 students. So you have your first student and then you have your 100th student. Right. So there was a score of 138, which is probably at the end of the range, right? Because the range is $132. So some people might say 0, but probably not. They might say a low amount, and some people will say a high amount. But I'm suspecting that 138 is on this side of the equation, right? Especially with like the median, the mean and the median being so low, 138 seems to be like a really high number compared to the center, and it's like almost, it's like compared, like the range is about the same. So it's probably where this is at the end of the data set. So if I erase this and I replace it with the 38 here, the median is not going to change because the median is the middle number. So if you exchange a number here with a number here, that's not going to shift the center. But it will lower the mean because the mean is calculated by adding everything and dividing by however many. So your sum is going to be $100 less, and you're still dividing by the same thing, so it should be lower. Okay. So again, if you're playing with numbers and choosing them to put them in the calculator, I guess I'm not sure how you're calculating, because the median should certainly not decrease. Okay, so let's look again at StatCrunch. I will generate 100 values just like you did. So let me get a new table. Let's see, new data table. I'm going to do random numbers. Let's go from, let's see, if the range is 132.5, I'm going to go from 138 to 2.5. Just give me a second. So 138 minus 132.5. I'm going to go from 5.5 is the minimum and 138 is the maximum. Let's assume that was sort of the written down wrong and it was the highest value. And I want 100 of them. And I'm going to compute. Oh, okay, so it wants, I guess it wants integers. Alright, that's okay. I think there's a way to do them so they're decimals, but we can just have integers in here. Okay, so it gives me 100 different numbers. We're going to put them in here. Alright, we want to sort them from smallest to largest, so 6 to 138. Let's see. All right, then we're going to, I'm going to copy this column over. Put it over here, and I'm going to erase the 138, and we're going to write in a 38 instead. Okay, because that was wrong. You know, we can sort it again. Okay, so we can sort it again. Right, and if you 100 students, the median is going to be between 50 and 51. Okay, so if I look here, 50 and 51, it averages to 69.5. So the median does not change because there's no reason for it to change because you haven't touched the center of the data. You're just messing with the ends of it. Okay. So let's see. If I do the summary stats, I'm going to do var1. I'm going to find the mean and the median. Oops. It's the mean and median. Okay, so we got a mean of 70 and a median 70.5. Which is, mean is much higher than the example did, but I can't come up with exactly the same, you know, numbers as they had because I don't have the full data set. And let's do the same with var2. I'm going to get the mean and the median. All right. Okay, let me just 65, 50, 51. Just make sure that I have all the entire thing here. All right. Summary stats, columns, var1, mean, and median. All right, so, okay, so unfortunately, it does matter what the mean is. The mean is, in the example, is 30 or 31.52. So if my mean is too high, then that's going to make a difference. That's going to shift the median. Because if I replace the 138 by 38, and my 38 is smaller than the mean, then it sort of, it basically pushes it one space. Let's see if I look at this. It's this, okay, cool. All right, if I replace this with 38 and I put it up top here, right, or at 38 in here, then it's going to kind of push down this column and it's going to shift the median, okay? But this is because my mean is too high here. So if we had the same data set with the mean is like small, then the median is 30, then the 38 is going to, okay, I see. I'm trying to think through this. So the 38 doesn't go there, right? So basically, if we look at, I have the median here. So the original median is 30. And I have this 138, which was written down wrong, and we want to replace it with 38. Then the 38 is going to go here somewhere because it's not going to go on the other side. Okay? So median is 30. The new number is going to the right of it. So this is not going to change how many numbers you have on this side and how many numbers you have on this side. They're going to be constant. So unfortunately, I can't kind of come up with a good data set in StatCrunch because I can't generate something that has exactly the mean and the median here, so it's going to mess it up, right? Unless, let's see, let me just see if I can do it if there's a different random number generator. Sampling distributions. No. All right, let's look at 16. All right, so 16 has to do with you're looking at trying to estimate the standard deviation. So basically, it says like no calculations are necessary. So you're not meant to do the calculation for this. You need to kind of do a rule of thumb or an estimate. So a rule of thumb for estimating standard deviation is that it's going to be the range divided by 4. Okay? So in the first one, you have 49s and 51s. So like the range is 2. 2 divided by 4 is about 0.5. And I think you only have integers for answers. So kind of round it up, it rounds up to 1. So this one, the answer was 1. Right? For this one, the range, it goes from 31 to 62. So the range is going to be 31 divided by 4. This is like 7.75, which is approximately 8. Right? So where this rule of thumb comes from is that it says that like 95% of the data is within 2 standard deviations of the mean. Right, this is like if it's a normal distribution, like a bell curve, but even if it's not a bell curve, you can sort of, that's a good way of estimating, right? So 95% is pretty much 100% is within 2 standard deviation of the mean. So basically that says like almost your whole range of data, with very few exceptions, are going to be like 2 standard deviation from the mean, so 2 up and 2 down. So the entire 100% of the data almost can be divided like in 4 different parts, in 4 standard deviations. So that's why range divided by 4 is a good rule of thumb for remembering what the standard deviation, calculating quickly what the standard deviation is approximately. If you wanted to be more precise, then you would put it in the calculator and figure it out. But this is meant to be with no calculators, okay? All right, 19 also has to do with that standard deviation. So kind of approximately 95% of the data is within 2 standard deviation of the mean. So if you are given the mean is 6.6 inches and the standard deviation is 0.8. So if you add 0.8 and another 0.8, you get 6.6 plus 1.6 equal to 8.2. Right? And then if you subtract 0.8 and subtract another 0.8, so you're adding 2 standard deviations, subtracting 2 standard deviations, you get, that's not right, 6.6 minus 0.8 minus 0.8, you get a 5. So those are like approximately the extremes, all right? Again, it's kind of that rule of thumb, right? The range divided by 4 gives you the standard deviation, right? So if you look at these answers and you figure out what the range is and you divide by 4, then so it's this one, right? Alright, so if I do 8.2 minus 5 and divide by 4, this gives me 0.8, which is, that should approximately be the standard deviation. Alright, I think that's all the questions you had.